this video we're going to look at a problem involving the speed of a particle. So the setup here is you've got a projectile fired from a cannon or something like that, and it follows this path through space. X of t is 40t, y of t is given by this parabola for t between 0 and t1. And the particle is fired off when t equals 0 and it hits the ground at t1. And we've got several things we want to work out here. It's typical of a projectile, of course, to be following a parabolic arc. That's what happens under constant gravity. So our first question is T1. When does the particle actually hit the ground? Or the projectile, I should say. Well, what we want, of course, is when y is 0. We're assuming, in fact the question sets up this way, that the x-axis, y equals 0, is the ground level. So we need the zeros of y. Well, this is just a quadratic, as y of t is, let's take that factor of 5 out, minus 5 into t squared minus 8t minus 9. We can simply factorize that as minus 5 into t plus 1 times t minus 9. So t1 must be 9. Second, in fact, what the question has been set up with, because t1 is obviously bigger than 0, so it can't be minus 1, which is the other root. So that's when the particle hits the ground. The next part of the question is we're asked what's the particle's speed at the time it hits the ground. Well, for that we need to know the speed of the particle here, and simplest here usually just to calculate the square of the speed and work with that. The speed squared by definition is dx dt squared, which I'll write as x dot squared, plus dy dt squared y dot squared. Adds at an arbitrary time t, and in our situation here x dot is simply 40, so we've got 40 squared, plus we'll differentiate y here, and we're going to get minus 10t plus 40, which, well, taking out a common factor of, well, 10, in fact 10 squared, we're going to get 10 squared into 4 squared plus, we can write that thing there as t minus 4 all squared. So that's a speed at an arbitrary time t. So at impact, which is when t equals 9, the square of the speed is 10 squared into 4 squared plus, well, that's going to be 5 squared, of course, which is 10 squared times 41. So the speed is the square root of that, which is 10 root 41 meters per second, which is about 64 meters a second. For the next part, we're asked to find the average height of the particle. Now, the average height here, we're just going to take y, integrate it, and then divide by 9, which is the total time it takes to travel the distance. So what we want is the average height, which is, we'll usually notate this as y bar. Y bar of t will be 1/9 integral from 0 to 9 of t, which is our minus 5t squared plus 40t plus 45 dt. Now this is just a straight calculation, of course, it's high school work really, but we can do the integration. We could write the integral down, but we can just as well do the integration and substitute as we go, because the lower limit is 0, so we don't need to know what's happening there. We're just going to have a polynomial, so it's not an issue. So we're going to get 1/9 of, well, integrate at minus 5t squared, we get minus 5t cubed, so we're going to get minus 5 upon 3 times 9 cubed. Integrate 40t and we get 20t squared, so that's 20 times 9 squared. Integrate 45 and we get 45 times 9. One could stop there, that's the answer, of course. Put it into the calculator and work out what it is. But if you're doing it in your head, well, divide out those factors of 9, so that just becomes a 45. That's 20 times 9, which is 180. And what have we got here? that's minus 5/3 of 9 squared. Well, 9 squared is 3 cubed, so, sorry, 3 to the 4. So we get minus 5 times 3 cubed, which is minus 5 times 27, plus 45, plus 180, which if memory serves is 90. So that's the average height. Okay. Now, we could work out from x, of course, just by putting in t equals 9, that the horizontal distance the particle travels is 360 meters. The last part of the question actually asks us to calculate not that, but how far the projectile goes in space. So that's really asking us for the length of the arc when it travels along this path. So that's what we're going to do next. We want to calculate the distance the projectile actually travelled, which means we're going to have to find the arc length of its path, which means integrating the speed of the path, which in this case is actually the speed of the projectile. Now, that's the formula that we had before for the speed, 10 times the square root of 4 squared plus t minus 4 squared. I've left it in this form deliberately for reasons you'll see shortly. So what we want to do, we want to integrate this from 0 to 9 because that's how long it took the projectile to actually travel. So we want the distance, which I might as well call d, is the integral from 0 to 9, let's take that 10 out there, the square root of 4 squared plus t minus 4 all squared dt. So this is the integral we're faced with. Now, there are two possible ways one can do this. It's square root of a quadratic, and it's a quadratic with a positive leading term. So we can either use tangent substitution or we could use hyperbolic sine. I'm going to do this one with the trig one, the tangent substitution. But you get the same answer out either way, of course. So we will put t minus 4 equal to 4 tan theta. So, well, first thing we're going to do is sort out the limits as well. So we can say that if t is 0, then, well, we're going to get tan theta is minus 1. In other words, theta is minus pi over 4. At the upper limit, which is 9, we're going to have tan theta is 5/4 at t equals 9. Tan theta is 5/4. So our upper limit is going to become the inverse tangent of 5/4. Well, I don't want to keep writing that down, it's going to be very messy. So I'm going to use a standard trait. I'm going to abbreviate inverse tangent of 5/4 by some other letter, and I might as well pick alpha. So let's let alpha be tan inverse of 5/4, just to save me doing a lot more of extra writing. Okay, so now we can do our substitution. D is going to be 10 times the integral from minus pi on 4 to alpha. I'm going to get 4 plus 4 squared, I should say, plus 4 squared tan theta so, to the half, so pull that factor of 4 out. I get 4 into 1 plus tan theta to the half times the derivative of tan, which is going to give me a 4 sec squared theta d theta. Now, that should be tan squared, of course. 1 plus tan squared is sec squared. So I'm going to get 4 times, I'm going to have a sec squared to the half. I'm going to get a sec cubed in here, and factors of 16, of course. I suppose I might as well write that down. Is 160 times the integral from minus pi on 4 to my unknown alpha sec cubed theta d theta. Now, you might remember sec cubed theta is a standard integral. It's a rather obscure standard integral. It's not that obscure. Or you should be able to, of course, calculate what it is, because it's one of the ones that we looked at the beginning of the course. You split this up into, well, it's actually sec theta sec squared, and do a suitable substitution, fractional integration by parts. Now think about it. What you get for the integral of sec cubed is 1/2 sec theta tan theta plus log of mod sec theta plus tan theta. I'm just going to write down the standard integral. I'm also going to move the 160 to the other side because I don't have to keep writing it down. So d over 160 is 1/2 the values we want sec theta tan theta plus log mod sec theta plus tan theta between my minus pi on 4 and alpha. Now the way we've answered the question, I'm going to stop there, but we'll put the values in. Let's put the 2 on the other side, so d over 80 now is, well, we need we know tan of alpha is 5/4. What sec of alpha, we'd have to draw a little triangle, draw a little right angle triangle, and you should find that, of course, the hypotenuse would then be, well, root 41, so we're going to have root 41 upon 4 for sec of alpha, so we have root 41 over 4 times tan of theta, which is 5/4, plus log mod, well, we've just worked out sec of theta, of course it was root 41 on 4, plus 5 over 4, minus everything at pi on 4. Well, tan of minus pi on 4 is minus 1, so we get minus 1 times sec of minus pi on 4 is actually root 2, plus log mod, well, that's going to be, in fact, root 2 minus 1. Now, one can leave it like that, I suppose, but we've got log of 5/4 plus a quarter of root 41, so we can pull out a common factor of log of a quarter. Log of a quarter will be minus log of 2, so we're going to get a minus log of 2 out of that. That's going to become a 5 root 41 over 16, multiply through by 80, and we get, let's see if I can get this right, d will be, what were we left? We're left with a 5, so we'll get 25 root 41 plus log 5 plus root 41 minus, times 80 in here, I missed those out, minus 80, 160 log 2 plus 80 log, root 2 minus, it is, log root 2 minus 1. Pretty untidy number, put it in your calculator and work out what it is. Now I should warn you here, by the way, that if you were to just put this integral into Maple or Mathematica, you might get an answer of a slightly different shape. It might not treat these logs exactly the same way. It might think of minus log root 2 minus 1, well, that's the same as log of root 2 plus 1. So you could change the sign here and the sign there, and that would be the same number. And something similar can happen with the 5 and the root 41s. But I'm going to leave it like that.